Is it adjusted already? All right. Okay, let's start. Yeah, good morning, everybody. So we'll review fully differential unity gain buffer in homework 5. And then we'll go to the switch capacitor integrator, switch capacitor gain stage, and switch the capacitor, or actually auto-zero the switch the capacitor integrator. Okay? So first topic is fully differential unit gain buffer. Yeah, we have some problems. So Mr. Zhang, he's not here. He found a solution for it. Okay. So the first one is a single-ended version of fully differential, unity gain buffer. Yeah, you see this. If this gain is A, yeah, we know my VO is so this is approximately VI, right? Yeah. Similarly, in a fully differential version, we want unity gain buffer. We cannot make it this way, right? So yeah, say if I just copy this one into fully differential version, it's very weird, right? VIP. So I want to connect this thing into VOM and PIM negative input. I want to connect it into VOP. And then this is nothing, right? This input and output shorted together. This is not a circuit at all. So I need a 4 input to make a unity gain buffer for the fully differential circuit. Okay. So I have say 2 positive input and 2 negative input. So we already see this differential output is just this gain GMRO. Yeah, this GMRO is my same as voltage gain A. If I connect this one of positive input to negative output, okay, one of negative input into one of positive input VOP, then we can get unity gain buffer. Yeah, in a previous class we connected this way. I make VIP and VIM. So I have a differential pair, okay? And then we got some problem, okay? They are connected together. What was the problem? Okay, here say I have IP and IM there. Yeah, this is just a fully differential op-amp. To make a unity gain buffer, so we added another differential pair. Current source must be separated, right? So we ought to make this one into half, right? 3.3. No, we can make a same GM, same input transistor. So yeah, so this thing is connected to D1, and this one is connected to D2. Okay, this is D1, D2. Then for the first case, this IP place we put BOM, right? Or unity gain feedback. this IM place we put BOP. Okay. Yeah, we did the same thing here. Okay, just have 6.5.7, and then we repeat the same thing here. So this is connected to D4, this is connected to D5. So for the IM place here, we put BOP, we put BOM. Looks like it should work, right? However, it didn't work. It's just something like that. So, you know, this is actually time. My input BIP changes from 0 to 3.3 volt. My BIP changes, BIM changes from 3.3 volt to 0 volt. Then my output, which is VOP here, yellow one, and then this red one is VOM, so it doesn't track, right? So I wanted a differential output is the same as differential input, okay? So however, in this very narrow range, it works fine, right? Here, it doesn't work, okay? So it doesn't work. You know, differential output is only this much. My differential input is this much smaller, right? Yeah, what's the problem? Yeah, Mr. Zhang found a solution. Yeah, the problem is, see, this differential pair has a very narrow input range. You know, in our differential pair, say we put VIP, BIM, and also another version is BOM, BOP, right? So those two are connected together, and those two are connected together, okay? So if, for this case, say, this one, say, for example, this is I1, I2. So then in this case, my differential current, VIP minus VIM, should be look like that. 0. So this is IO, tail current source, minus IO. Here it's 0. So it is linear in very narrow range of differential input voltage, right? If my differential input voltage becomes larger, then it is very nonlinear, right? So, yeah, Mr. Zhang Yongje found a solution. Looks like it's good. Yeah, he found a solution. See, instead of VIM, we put BOP here, okay? Instead of VOM, we put VIM there. Okay? Yeah. So then what happens? See, in this case, let's just say, I assume this current is 3 and this current is 4. All right? Then, so I want to calculate I3 minus I4. What's I3 minus I4? Oh, maybe, yeah, I just put 5, 6, okay, 5, 6. This is 5, 6. This is I3, I4. Then I5 minus I6 should be I1 minus I2 plus I3 minus I4, right? What's I1 minus I2? I1 minus I2 is just GM there. Yeah, this is GM. Yeah, just a half GM, VIP minus VIM, plus half GM, VIM minus VOP, right? Yeah, see, this I3, I'm not sure exactly. Let's just see. This thing is connected to somewhere. Let's just see. Let's go to the original circuit, whether this works or not. So here, see, yeah, Mr. Zhang's idea is just replace this thing, BOP. Huh? Oh no. Yeah, there is another version, right? Another differential pair is just like that here, and then this thing is connected to D1. This thing is connected to D2, and then here in this let's see. Ooh. This is IP, right? So this should be IM, minus input, okay? Yeah, this should be OM. Yeah, in this case, say if my VIM is close to BOM, no problem for the very narrow linear range, right? VOM tracks VIM. Yeah, similarly here, BIP tracks BOP. So very narrow range, it doesn't matter in this case. Okay, let's just see it doesn't work or not. So here our P is there. Yeah, we just calculate this is I5, I6, right? Then this I5 flows through here, flows through, yeah, that's I5, right? That's I5 is flows through there. How about this thing? I6, right? Where's R6? R6. I6. Oh, no, it's a negative, okay? So here, VOP minus VOM should be this current, I5 minus I6 times RO. And it should be, there is a minus sign there, right? Because it's flowing out. So if there is a arrow there, it just flows out, okay? Flows out. Then this VOP minus VOM should be, let's look at the, what was that? It was just half GM. Let's go to the previous slide. Oh yeah, where is it? Oh yeah, here. Just half GM, IPIM. Is it IPIM? IPOP, right? Oh, sorry. IPOP. Yeah, this is IPOP, right? Oh, and then IMOM. IMOM, right? Is this IMOP? IMOP is fine. Okay. IPOP, IMOP. Oh, is this negative there? Oh, no. IPOP, IMOP. How come they are added together? Something wrong here in the polarity. Okay, let's check. This I3, I5, right? IP. Oh yeah, I put wrong place. Is it right? How come I put wrong place? Let's just see. VIP, BOM must go to the different place, right? This is OM. Oh, sorry. Yeah. This is wrong. This should be VIM. Okay? Now, this VIP flows through, flows current, add current I5. This VIM must add current into I6, right? So this is good. Okay? Question? Nope. Okay. IP minus OP plus OM minus, this is wrong, totally wrong. OM minus IM, okay? OM minus IM. OM minus IM. Okay. Yeah, this is my current. Then what's OP minus OM? Yeah, so I have a OP minus OM there. OP minus OM. Oh, how come? This is positive. Huh? I have some problem here. OP minus OM. IP minus. I have to check again. Okay, let's do it again. Some polarity mistake.
저게 지금 그래프가 완전히 볼티지가 내려가게 나오는데 GM이 흘러가 있잖아요.
예.
그래서 제가 옛날에 배울 때는 저 디퍼런셜 보스 아래 저항을 양쪽에 달아주면은 GM이 안 좋아지고 리니얼러티가 됐으면 이렇게 좋아진다고 배웠는데 그렇게 해도 안 되는 이유는 뭘까요?
Okay, question is okay. Let's talk about that question first. So yeah, question is this. Say the voltage range problem is caused by very narrow input range. So my linear range is very much limited. Then the question is, if I make this GM, actually this slope is GM, right? This slope is GM. So I reduce GM by adding a resistance. So question is, so can I make it like that? Then my linear range is pretty large. By adding a series resistor there in a differential pair. Yeah, that's your question, right? Yeah, you can make it that way. However, in this case, your gain, your GM is pretty small, right? So this may not be exactly 1. This may be 0.8 or something smaller than that, right? It doesn't exactly trace input, output. Yeah, that's no good. Mr. Zhang's solution looks better. Okay, let's try again. Oops, I don't have